Okay, that's right. Thanks. So Roy should have been here, but his visa has expired, so I'm here on his behalf. So okay, so I'm going to be talking about like access control, most boring topic in the world, but I'll try to keep it moderately entertaining. But what can you do? It's access control. So just like everywhere else, in IoT, there are a lot of situations where various access decisions are made. So you have things like apps accessing cameras, various devices that perform actions automatically, and then user has to be. And if you look at these policies, you quickly realize that very often it's not like the same old access control policy you've seen everywhere. Very often they have conditions attached to them. And not just any conditions, but things that have to do with the state of the world outside of the system. Like, for example, if you look at common policies for controlling access to things like cameras, you would see like little kind of constraints attached to them that look like this. It's okay for an app to access the camera, but only when the user is not at home. Another example of a constraint attached to an access policy is some action that needs to be performed after access has happened or before access has happened. And you see these things like, for example, on automatic garage openers, you'd see things like if an action has been performed, then the user has to be notified. So if you notice this, kind of the next question to ask, so wait, so is there some rhyme or reason to these constraints that are attached to policies? And it turns out that there is. We went and we looked at a whole bunch of IFTTT recipes or applets. And for those of you who don't know what IFTTT is, it's a very popular way of integrating functionalities like devices and apps. It's the kind of thing that says, you know, I have a dog feeder, and if the dog feeds, then post a picture automatically to Instagram type of integration. Like, I kid you not, that's actually a popular one. People love their dogs. And if you look at these policies, you actually notice that a lot of them are constrained. So a lot of them have this additional extra thing to them. And these things, and some things are very common. Like, for example, a lot of them have to do with the user being at home or not being at home, or the user arriving or leaving. So if you look at various triggers for IFTTT applets, this thing about entering or leaving an area is actually very, very common. It's among the top 3. And as I already mentioned, for a lot of things that involve activating devices or devices performing some physical action, they're often constrained with things like notifying the user or emailing the user, which is another form of notification, or at least logging this somewhere. So these are actually like top actions if you look at the statistics of these things. And as a matter of fact, this thing about attaching notification requirement to the policy is so common that it's actually enabled for every IFTTT applet, which is very unusual because typically these applets, I mean, they try to keep to the minimum the number of things that are included in every applet. And this functionality is so essential for all of them that it's actually present in everyone. And this is a challenge for kind of conventional thinking about access control policies, because once you look at this, you realize that a conventional access control framework that's kind of a thing in itself, which is just an access policy and a reference monitor and so on, is going to be pretty hard to apply here because it's just not going to work. There is no way to make it work because it makes references to all these things and actions that are actually outside the system. And people have been talking about kind of situational policies or context-aware policies for a long time. Like back in the 90s, there were all this kind of sci-fi type scenarios about how context awareness is upon us. But in this day and age, it's actually not insane to be thinking about a pretty wide variety of various contextual and situational policies, mainly because we now have devices, actually commodity devices like motion sensors and watches and fitness sensors and audio microphones that are always on, that actually do provide some information about context, meaning that if you do things right, you can imagine that you can actually implement these access control policies. So now that you realize that this situational dependence is there, you kind of think, wow, I mean, that's pretty good. Like, for example, for detecting that the user is at home, it's an important constraint for lots of policies. And fortunately, today, we have lots of ways to detecting it. It could be based on face detection or sensing presence or something in the phone that communicates your location. Same way for notification. We now have a million ways of notifying users, from like flashing lights to push notifications on their phones. So you'd think that's how existing frameworks are going to do it. They're going to take advantage of all this richness and kind of write and implement meaningful meaningful access control policies that are constrained with situations and so on. There are more sophisticated policies out there. They're not as common, but if you read the literature or even look at what people are trying to implement using IFTTT things, you discover that there are like other kinds of constraints. So like user being at home is not the only one. Some things should only be operational when the user is awake. Then there are for physical access, apparently what's important to people, and this is based on user studies. This is what users want. They want certain things to be activated only if the user is nearby, or if any person is nearby, if the operator is an adult, when kids are not at home. So when you talk to users, you discover that that's what they actually seem to want from these devices. So that's kind of what people want. So let's talk about what we have instead today. So let's look at how the simple situation of the user being at home or not being at home is inferred in today's IoT. So if you look at a common framework like SmartThings, so what happens is, like, for example, a lock should open when the user is nearby. How does it detect that the user is nearby? In a pretty interesting way. So the only way for it to detect it is to talk back to some cloud service. And the cloud service has to talk to an app that must be installed on the user's phone. The app has access to location. And the app communicates to this cloud backend that the user's location, as read from the phone, is within a certain prescribed perimeter. And it turns out that if you have other devices, maybe from other providers, each one of them needs to have an app installed on your phone, which has to obtain the geolocation from the phone, determine if it's within a certain perimeter, talk to the backend, and then the backend tells the device that it's okay to operate if the policy is constrained by the user being at home. So in addition to being extremely kind of clunky and redundant, and the same thing is being implemented like sort of 3 different ways, which are kind of the same but not really, you also have a pretty severe overprivilege problem here, because now in order for any of this to work, effectively any device needs access to your location as comes from your phone. Just in case you happen to be within the prescribed perimeter where it's okay to perform a certain action, each one of them needs to be tracking you all day, every day, just so it can give you access when you're within a certain perimeter. And this has to happen for every device. What's also pretty bad here is that if you look at how this is implemented, there is no distinction between policy and implementation. So in some ideal world, the policy here is only give access if user is at home. In reality, it's only give access if user's location, as reported by my own app on the user's phone, is within a certain preset perimeter. And this is not good, this entanglement of policy and implementation, because effectively it bakes everything bad that I mentioned, like redundancy and overprivilege. This becomes directly part of the policy, because in the implementation of access control and these things, policy and implementation are not separated at all. There is no like high-level semantics of situations like users at home. Everything is done in terms of kind of low-level interfaces and conversations with the user's phone. So just to kind of summarize how things are not good in the existing frameworks, you have a bunch of them and a bunch of devices, a bunch of apps that separately track same situations. You have an overprivileged problem. It also happens not to be expressive enough. It kind of only supports very coarse policies, because with this implementation being part of the policy, it's kind of hard to be fine-grained. And actually, these policies aren't even the right policies. They don't map onto what users want. And again, because implementation is part of the policy, it's all kind of very rudimentary. So even though there are many ways of detecting presence, pretty much all of them rely on like geofencing for notification. They rely on pushing information to the user's phone, because that's all you can do if your implementation is part of the policy. So at this point, you could be thinking like, wait, I mean, I've heard this before. I mean, this story is not a new story, because this dependence on situational factors has been explored before, and indeed it has. In particular, it has been explored. There is like a stack of papers like this thick on situational or context-dependent access control in Android. So it seems like you can just take Android and copy it over into IoT. Unfortunately, that idea doesn't quite work because access control in IoT is decentralized. And what I mean by this is just let me draw kind of a distinction between IoT and Android. In Android, you have a platform that controls everything. On top of that, you have APIs and reference monitors provided by the platform. And then you have an app runtime that works nicely with this reference monitor. And effectively, everything is mediated by the platform. But in IoT, you don't have like one such platform. What you have instead is a whole bunch of different devices. And that's pretty clear. I mean, if you think about like getting access, even just very basic thing, just based on phone-based geofencing, there is no single framework that provides everything that you need to make an access control decision, because even if all the apps are running on a particular platform, it still needs to go and talk to the phone and interact with the phone API and reference monitor and stuff like this. So, and this makes porting like existing approaches from Android to IoT infeasible because they make assumptions about the environment that are just not true about the IoT. Such as there is no single policy and reference monitor, there is no common sandboxing, reference monitors in IoT are actually distributed, and they actually themselves need privileges to access protected APIs and other frameworks. So this is what we have today, and we have a better idea. And the better idea is very simple. I think that makes it actually good, I hope. And it leverages this fact that in reality, there are many fewer policies and, I didn't say this right. There is a small number of situations that matter for a lot of policies. And every time you kind of have this one-to-many relationship, you kind of know what to do. You need to like abstract away the small number of policies, I keep saying the small number of situations that matter for a lot of policies. And if you provide the right abstraction as part of the system, as a first-class object, then you can write policies that depend on these situations. And that's our idea. That's an idea of environmental situation oracle, which is part of the IoT ecosystem. And it's a very simple kind of functionality. It has a backend, and on the backend, it's responsible for actually tracking the situation, which, for example, in case of user being at home, might involve interrogating the phone and finding out its location, or it could be based on face recognition, or could be based on sensing presence in some other way. Doesn't matter. What's important is that on the front side, that is to the client access control frameworks and client applications that have to do access control, it exposes this very simple interface, which basically tells them if the user is at home or not. And it encapsulates this sensitive functionality. So now only the back end of this thing actually needs access right for the phone. And it segregates it from the rest of the framework, meaning that the rest of the framework doesn't need to worry about the low-level implementation of details of how the situation is sensed. It can be written strictly in terms of constraints that rely on these high-level oracles and high-level situations, like is the user at home. So that's what an ESO does. It tracks a situation, exposes it to authorized clients via universal interface. And I won't go through what makes a client authorized because that's kind of a little to the side, but hopefully you get the basic idea of encapsulating and segregating the situation tracking functionality and making it available to a bunch of users. So what are the advantages of this approach? So there are a bunch. So first of all, these things are what I would call least privileged declassifiers. So in terms of sensitive information that's actually needed to track the situation, such as access to location on the user's phone or access to face recognition functionality, these are the only ones that need it. The policies that depend on this don't need this anymore. You don't need redundant implementations. There is mutual obliviousness between ESOs and whoever uses them. So they can be, the latter can be done strictly in terms of policy and high-level situations. They don't have to worry about implementations. And as we show, it's actually pretty straightforward to take existing policies and existing implementations and kind of re-engineer it around this concept of an ESO so that you can kind of support what people already we know want to do, and what they do, you can support it in this new world of ESOs. So the interface of an ESO that faces the client, which in this case would be an access control policy or a reference monitor that needs to enforce a situational policy, is pretty simple. It's accessed via URI, and it has only a couple of methods. One of them gives the description of the ESO and explains the situation it tracks and so on. And this is nice because now you have separation between policy and implementation, and ESOs could be grouped or selected based on the actual situation they track, not based on how they do it. And then there is a super simple, like basically a binary predicate. If you're an authorized client, you can ask the ESO, is the situation active or not? Like, for example, is the user at home or not? Some of these have side effects, like, for example, notification, but again, it's kind of a binary thing, like, please notify the user, done and done. So it's very simple from the client perspective. Okay, but of course, like, the concept is simple, and I view this as a good thing, but integrating into the existing IoT world is a pretty non-trivial exercise because you need to integrate it into the IoT stack and find the right places where to do it. And you actually need to change existing policies and enforcement to support situational constraints. So the second part actually happens to be pretty straightforward, so I'm not going to talk about it, but I will briefly talk about the first part because that's where kind of the low-level technical details lie, and that's kind of the painful part to get right, and that's what takes, several months of implementation, is this part. And the reason for that is that the IoT stack is pretty big and pretty messy. And actually a big part of it, maybe this is like known to everybody who works in this field, but for us actually to even understanding what that stack looks like it took us some time. Because at the low level, you kind of have these communication protocols like Zigbee and whatnot that deal with addressing and routing and actual communication. And then you have resource layer on top of that, which is like an operating system responsible for provisioning devices and assigning identities and so on. And they expose some device capabilities. And on top of that, you actually have device services, and these are typically things that user would interact with. And these are things that have like web interfaces that users can use to configure devices. And on top of those, sorry, I have to mention this because often like you see integration between IoT and non-IoT devices. Sorry, between devices and kind of non-device things like, post dog feeder pictures to Instagram. And so this is also part of the ecosystem. And then on top of that, you have app frameworks that give third-party apps access to the devices. And furthermore, these apps are integrated with each other via things like IFTTT triggers and actions and IFTTT applets that integrate their web APIs. So this is a pretty complex software stack. And in order to convince anybody that ESOs are actually a reasonable approach to doing access control here, we need to identify where access control is happening. And it's happening in a whole bunch of places, like it's happening in the resource layer. So this is kind of getting access to a device in the resource layer is similar to how a process gets access to a file in the operating system. It happens when apps try to access the API. It happens at the service integration layer. And it also happens when IFTTT applets try to pull a bunch of services together. And what we've managed to do, we discovered that by providing just two types of ESOs, we can cover about 90% of this by providing ESOs at the resource layer and at the web service layer. So if for reference monitors that need to enforce situational policies, kind of in the local network, not through the web, like working directly with the devices. It turns out that this resource level ISOs are enough. And for services that perform access control at the web layer, like for example, when IFTTT applets are constrained in various ways or depend on situational factors, we could do this by adding ESOs at the web level. And so between these two types of ESOs, like I said, we pretty much cover everything. So I'm going to skip over the gory details of how these things are implemented in the web layer and in the resource layer. You can read the paper if you care. It's all kind of pretty boring and painful. But the good news is that once you do it, we can show that it's pretty widely applicable. So in different access control systems at different levels of the IoT stack, this concept of an ESO seems to provide the right abstraction, kind of neatly encapsulate situational factors, and then you can take existing policies and re-engineer them fairly simply so that constraints are expressed in terms of ESOs, not in terms of low-level details. And you really need very minimal assumptions about what your IoT ecosystem looks like in order to make this work. So just in terms of implementations, we at the resource layer, we prototyped it in the IFTTT library, which is, I mean, the reason we chose it is because it's open source. And at the web level, where things tend to be easier because more things are open source, we use the modification of the Passport JavaScript library to implement it using Web API with auth integration, which is another extremely painful thing. But conceptually, the two are very similar. So you have subjects, you have operations, you have access rights, which I use slightly different language at the resource layer and at the web layer. But conceptually, I mean, this is same old access control policy, except that it is now equipped with situational factors. So this is kind of how much you need to change in order for this to work. So, you know, in a resource layer, it's something like 1,500 lines of code, not a hell of a lot, but it's tricky because you need to, like, I mean, there are systems aspects of it that are painful that I'm not going to talk about. And using this, we actually managed to implement a few fairly simple case studies, including support for existing popular policies, and showed that it actually works pretty well with very reasonable performance overhead. Like the main source of performance overhead is the fact that when enforcing the policy, you have to make this external reference to this ESO that actually implements the situation. So that takes the most time. And we've managed to demonstrate that at least a bunch of common policies can be implemented in this way. So that's pretty much it. So what I hope you take from this is, A, that access control policies in IoT seem to be heavily dependent on various situational and context-dependent factors. B, you're not going to be able to just take Android solutions and move them to IoT because everything in IoT is decentralized. And to track situations, you need to be talking to other devices, other reference monitors, other APIs that are outside your framework and outside your control. C, that a small number of situations seem to be responsible for the lion's share of situation-dependent functionality in access control policies. And that gives us this kind of nice abstraction, the abstraction of an ESO, which encapsulates situational factors and enables any access control policy or any reasonable access control policy in the IoT stack, no matter whether at the resource layer or at the web layer, to incorporate it into situational factors into access control decisions. That's about it. That's all I had. Thanks.
We have time for a few questions. Please come to the microphone and state your name and affiliation, please.
Hi, I have a question. Can you tell me more detail about how you implement WESO based on OAuth? Because, as far as I know, can you tell me what is the entity of OAuth?
Okay.
For example, the resource server, authorization server. What are those?
Short answer to your question, how implemented based on OAuth is extremely painfully.
Yep.
And let me refer you to the paper for more details and to the implementation. I'm just not going to be able to answer it within 1 minute standing here.
Okay, yeah. And also in the IoT stack you just showed us, I think the IoTTT also has a service layer, right? The IoTTT framework, they also has a layered different types of stack, pretty much like what you're drawing in your slides.
Yeah, and we used it mainly as the resource, just the resource layer in it.
Okay.
So we did not look at what's above it, mainly because it's not used all that extensively. We needed IoTTT. Like I said, we needed something to experiment with in the resource layer. And the only reason we picked IoTTT is because that's the only one that's fully open source, that doesn't have to contain this closed source pieces. But we wanted to show generality in higher layers, so we kind of didn't commit to IoTTT full on. So
yeah, thank you.
Hi, Lorenzo Di Carli, WPI. First of all, I did not find the talk boring at all, so thank you for that.
Thank you. I'll take that as a compliment.
Yes, it is. So I understand the technical advantage of your approach in terms of flexibility and expressiveness, but to latch on your user location example, there is an obvious concern about user privacy there. So what is the fundamental reason why this framework would be a better root of trust than whatever Google or Honeywell have out there?
Right. So that's a great question, okay? And my only answer to this is if you do it this way, then you know exactly who has access to your location. It's this ESO thing. The way IoT works today is that any kind of device, from your fridge to your car to some, IoT bobblehead doll that starts bobbing when you're in the vicinity, needs to run an app on your phone that has access to your location. So this is just based on kind of this very simplistic reasoning that in terms of privacy, like 1 is better than some number greater than 10, which is how it is now, okay? Is there any reason to trust this ESO? No, maybe the answer is let Google implement this ESO, and like everything now is concentrated on that one, and everything depends on that Google ESO, and you trust them as much as you trust Google. Sorry, I don't have a better answer.
Okay, that makes sense. Thanks.
Yeah. So this is Sam Weber from Scilab. 2 related questions. The first one is, I'm a little bit puzzled by your talking about this as if it was an access control policy. It seems like, for instance, taking a picture of your dog whenever your dog eats isn't an access control problem.
Well, okay. So it's not like you're lashing onto the word control, right?
Well, I mean, it seems to be an event action system.
Okay, but it's part of the same thing. It's like you have something getting access to a device, okay? In this case, it's getting access to a camera, okay? Like you have an app getting access to a camera, and there is a rule attached to it that only when the dog is feeding, this app is allowed to post pictures on Instagram, okay? So what do you call this?
Yeah, well, an action event system. But
okay, fine.
That comes to the second one, because access control policies have the nice property that you deny unless you accept. But in many of these action systems, you have conflicting policies, and you can have policies that conflict. So
this is a deep question you're asking. So let me give a simpler version of it. Mm-hmm. So suppose you have a reference monitor that made a call to an ESO, okay, and nothing came back, because that's a remote service. So things don't come back from remote services often. Mm-hmm. So what is the right thing? Is it like by default assume that it's on, by default assume that it's off? You see what I mean, right?
Yeah.
And this is big part of what you're talking about, because all of a sudden when the situation, I don't have an answer to this question. Sort of, I feel our job here is to provide a generic abstraction that could be very helpful. But what to do if your policy or action event system happens to depend on a situational factor, and at runtime, you cannot even determine that that situational factor is true? That's not our bailiwick. That's above our pay grade, okay?
Right. Well, there's also the thing if 2 policies actually conflict in some situation.
Or 2 policies conflicting. And all I know is that for better or for worse, people write policies that depend on situations, okay? That's an empirical fact. And the way they track their situations, which is, again, independent of what they do if tracking fails, the way they track the situations is ugly. So I hope what we're giving here is a prettier way of tracking situations that are empirically important to a lot of people. Are they making the right decisions conditioned on these situations? I don't know.